Hi everybody! Today we're going to talk about the developing person through childhood and adolescence, and this is Chapter 1. Welcome to CD1. So what I am hoping you are going to know by the end of this chapter is how can the study of children, each one unique, be a science? Does his or her ethnic group make any difference in a child's development? Is childhood today different from childhood 50 years ago? How can we know what changes between 1 year of life and the next? Is it unethical to study children scientifically? And do scientists always investigate the crucial questions? So understanding how and why, the science of human development. The whole goal of this is we're seeking to understand how and why people of all ages and circumstances change or remain the same over time. So we're understanding how and why. And developmental study, is it a science? Is it multidisciplinary? Does it lead to practical application? Is it based on objective evidence? The answer to all of those is yes. So scientific method is a way to answer questions using empirical research and data-based conclusions. And there's 5 basic steps of the scientific method. The first one is curiosity, then hypothesis. Test the hypothesis, draw conclusions, and then based on the conclusions, you report the results. So on the basis of theory, prior research, or personal observation, pose a question. You develop a hypothesis and a specific prediction that can be tested. And then you want to test the hypothesis. You're going to design and conduct research to gather empirical evidence. When you're drawing the conclusions, you're going to use the evidence to support or refute the hypothesis. And then when you report the results, you're going to share the data and conclusions as well as alternative explanation. Built into the scientific method in questions, hypotheses, tests, and replication is a passion for possibilities, especially unexpected ones. Replication is the final step. If someone can take your research and replicate it using different participants, and they get the same results, then that is telling you that your research was applicable. So the method is not foolproof. Scientists sometimes draw conclusions too quickly, and they misinterpret data or ignore alternative perspectives, and replication is needed to verify those conclusions. So nature versus nurture is a huge topic, and you're going to have a discussion question on it later in the semester. And nature is all about the influence of genes we inherit, while nurture is all about the environmental influences included in such things as like a health and diet on the embryo's mother, family, school, community, and society. And you cannot have one without the other. Nature always affects nurture, and nurture always affects nature. So some people are more vulnerable than others. It's called differential susceptibility, and people differ in their susceptibility to environmental influences because of a particular inherited gene. So each domain includes several academic disciplines. The biosocial includes biology, neuroscience, and medicine. The cognitive includes psychology, linguistics, and education. And the psychosocial includes economics, sociology, and history. Typically, each scholar follows a particular thread within one domain, using clues and conclusions from other scientists who have concentrated on the same thread. So are children more important than adults or vice versa? Both are equally important to study. So, and it's also a challenge to include all kinds of people because we want to identify both universalities and differences and describing them in ways that simultaneously unify humanity and distinguish each individual. And the danger is drawing conclusions based on a limited group, or worse, to consider one own group normal and every other group abnormal. We have that happen a lot in our society, and it's something we try to stay away from, especially when we're looking at research. So it's important to include all kinds of people, and oftentimes the environment changes with time. So something that may have 50 years ago been looked at one way may be looked at differently now. An example of this is sexual orientation. It illustrates a difference that was once assumed to be a deficit. 50 years ago, we thought something was wrong with someone that was born with a different sexual orientation. It led to a lot of bullying of LGBT classmates, and they were more likely to be considered like they had a deficit and we were going to change them. Nowadays, because of activism and scientific data and cultural change, we are realizing that it's not a deficit. So, including all kinds of people is important. There's important definitions like culture, ethnic group, race, and socioeconomic status, which we shorten to SES. Culture is a system of shared beliefs, norms, behaviors, and expectations that persist over time and prescribe social behavior and assumptions. Ethnic groups are people whose ancestors were born in the same region and who often share language, culture, and religion. Race is a group of people who are regarded by themselves or by others as distinct from other groups on the basis of physical appearance, typically skin color. Social scientists think race is a misleading concept as biological differences are not signified by outward appearance. Socioeconomic status involves a position in society as determined by income, occupation, education, and place of residence, and it affects every aspect of development. SES is a complicated category. It affects almost every life aspect in every nation and in every region of each nature. Unfortunately, there's a widening gap between the rich and the poor at different ages. Income is part of SES. Government categories rely almost exclusively on income. Policies and practices vary from nation to nation. So finding the balance. In the science of human development, it's important to find the right balance between the universal and the particular, and it's necessary to guard against simple conclusions across or within groups. And a key to remember is that most categories are social constructions, not enduring divides. So there's something called a critical period, and this is a time when a particular type of developmental growth in body or behavior must happen for normal development to occur. Human embryo grows arms and legs, hands and feet, fingers and toes, each over a specific few days between 28 and 54 days after conception. After that, it's too late. And so this is called the critical period. Back in the 1950s, there was something called thalidomide, and this was given to pregnant women when they were very nauseous. What happened is they didn't realize until after the infants were all born missing some of their body parts is that thalidomide actually caused extreme birth defects. And so it wasn't until after the babies were born that we learned about that critical period when they got the medication is when it was a critical period for when these body parts were forming. Then there's something called a sensitive period, and this is a time when a certain type of development occurs more easily, although it may still happen later with more difficulty. And if children do not start speaking their first language between ages 1 and 3, they might do so later, but it's going to be much harder. And children who are severely malnourished at age 1 are more likely to become overweight and thus develop diabetes or heart disease in middle age. So patterns of developmental growth. Many patterns of developmental growth have been discovered by careful research. Although linear or nonlinear progress seems most common, scientists now find that almost no aspect of human change follows a linear pattern exactly. As time goes on, the ecological systems approach, which is Bronfenbrenner, each person is affected by many social contexts and interpersonal interactions. Nested levels surround individuals and affect them, approach later named bioecological theory. So each person in the ecological system, there's the microsystems, exosystems, macrosystems, mesosystem, and chronosystem. Each person is affected by interactions among overlapping systems which provide the context of development. So microsystems, which is the family, peer groups, classroom, neighborhood, house of worship, intimately shape human development. Surrounding and supporting the microsystems are the exosystem, external networks such as local, educational, medical, employment, and communication systems that influence the microsystems. Influencing both of these systems is the macrosystem, which includes cultural patterns, political philosophies, economic policies, and teachers coordinate to educate a child system. And the chronosystem to emphasize the importance of historical time. So an example is, let's say right now as I'm talking about this PowerPoint, there's a lot going on in the stock market. It's crashing right now. So let's say that your boss has invested money in the stock market. Even though you have no money invested in the stock market, your boss is suddenly very cranky and is putting a lot of demands on you at work. You go home and you get very angry with your children because you're irritable, you get angry with the dog, even though the macro system, which is economics, you would think may not impact the young child. It's impacting the young child because it's impacting your boss, who's impacting you, who's then impacting your child. So we're all kind of interchangeably related to each other. Then there's the historical context, which is our cohort. You're born within the same historical period. You move through life together, experience same events, new technologies and cultural shifts at the same ages, and influences attitudes and behaviors. And can people change? Any human behavior has multiple causes, and plasticity is possible, especially in the early years, but also lifelong. It's particularly evident during childhood, but change is possible throughout life. Dynamic system approach. A dynamic systems approach highlights the ever-changing impact that each part of a system has on all other parts. The dynamic systems, a view of human development as an ongoing, ever-changing interaction between the physical, cognitive, and psychosocial influences. The crucial understanding is that development is never static, but it always is affected by and affects many systems of development. So using scientific methods, we can statistical measures often used to analyze research results. We can affect size, significance, cost-benefit analysis, odds ratio, factor analysis, and meta-analysis. 3 basic types of research designs are observation, the experiment, and the survey. So observation is when we require researchers to record behavior systematically and objectively, and it may be conducted in a naturalistic setting or a laboratory, and it's crucial to development of a hypothesis. You will be doing an observation in this classroom 3 times to see a child's development. There's something called experiment, variables, and groups. The independent variable is the variable that is introduced to see what effect it has on the dependent variable. The dependent variable is the variable that may change as a result of whatever new condition or situation the experimenter adds. The experimental group gets a particular treatment, which is the independent variable, and the comparison group, also called a control group, which does not get any treatment. So how do you conduct an experiment? You can divide the participants into 2 different groups that are matched on important characteristics and give one group a special treatment and the other one nothing, and you're going to look at the results. The basic sequence diagram here applies to all experiments. Many additional features, especially the statistical measures listed in Table 1.7 of your book, show various ways of reducing experimenter bias, affect, whether publication occurs. And scientific journals usually reject reports of experiments that were not rigorous in method and analysis. So still using the scientific method, there's some other ways of doing research, and one of them is a survey, and that includes informally collecting, having people respond to some questions. You may have gotten those phone calls where they're like, we're just doing an informal survey, can you answer some questions? And challenges with this is that acquiring valid survey data is not always easy. Some people lie or change their minds, and survey answers are influenced by the wording and the sequence of the questions. For instance, did you have sexual intercourse before age 13? Depending on the person's expressions, many people may answer differently. I forgot. If this were the only data available, you might conclude that 9th graders have suddenly become more sexually active than 12th graders, because looking at the data, it looks like 9th graders had more sex than 12th. But we have 20 years of data. Those who are 9th graders now will answer differently by 12th grade. Studying development. There's basic research designs. The first one is cross-sectional research, and this is groups of people of one age are compared with people of another age. Then there's longitudinal research, collecting data repeatedly on the same individuals as they age. Cross-sequential research is studies several groups of people at different ages, a cross-sectional approach, and follow them over the years, a longitudinal approach. And which approach is best? Cohort sequential research is the most time-consuming and complex, but it yields the best information. Scientists replicate one another's work to gain some advantages of cohort sequential research without waiting for decades. Cautions and challenges from science. We have to be careful because of correlation versus causation. A lot of people think that because there's a correlation, it actually shows there's a definite relationship between two variables, and that's not always the case. A correlation is positive if both variables tend to increase together or decrease together. A correlation is negative if one variable tends to increase while the other decreases, and a correlation is zero if no connection is evident. But correlation is not causation, meaning that correlation does not mean that one definitely causes the other. And there's definitely cautions and challenges from science. Quantitative research provides data that is numerical and is best to compare children in different contexts and cultures. And it's easy to replicate, interpret, and verify because it's all about numbers. While qualitative best captures the nuances of individual lives and reports information without being quantified. So it's more about observations and looking at the kind of the quality of what's going on in the research or the child's development. For instance, vaccination and autism. There was suspicion of science and federal government has led some parents to not vaccinate their children. Some parents believe that the certain childhood vaccinations cause autism spectrum disorder. Is this true? We actually know that it's not true, but for some reason there was a lot of talk about it, and some parents thought, oh, because there was a correlation, one must cause the other, and this is not the case. And then there's ethics. Each academic discipline and professional society involved in the study of human development has a code of ethics. And in the U.S., most educational and medical institutions have an institutional review board. So before you can do research on any children, you have to go through this review board, and they can say whether it's ethical or not, because they don't want anything that's going to harm the child. And there's ethical safeguards. There's protection of research participants. And there also has to be integrity of the scientific study. And the ultimate thing is that science is a way to help humankind. The ultimate purpose of the science of human development is to help all kinds of people everywhere of every age live satisfying and productive lives. So now that we're done with the chapter, I would like you to go to your the discussion and respond to the discussion.